Dun, dun. Hey, welcome, welcome. There you are. Thanks for stopping by. Oh my gosh, it's early. Played way too hard last night with these things, but thought it's time to do a quick update. I don't want to get too far ahead without talking through things so that they can make sense and you can relate to them. So we are technically on our second sit. First sit, we grabbed the kids, got their machines built up, and slowly built just our first bit of code ever. Right? It's not best code in the world, but let's take a look. So really, that's it. Right? We had a calculator class. It took two numbers. It could add them together, and it could show them. Pretty difficult stuff. To make that more interesting, and the point of all of these journeys is really to get just enough interesting code up to learn some things, but to support the idea of automated testing. And so, really, the big focus throughout our time together is going to be what does it look like to get to those moments where all these different testing frameworks and all of that stuff becomes so important, and we can quit being so abstract or continuing to just say it's important and justify it, but never writing them. They are your friends. And to do that, kind of at random, we chose the old calculator. So this the story today that I'm about to tell you is the journey of a small robot that just wants to help people add and subtract, multiply, divide, these kinds of things. And in chapter two, it's a little bit cleaner, so I'm just going to start telling the story from here. If you haven't seen anything before, this will be fun. And we'll just start, we'll find that robot. He is technically hiding, or she, over here. So slightly more mature, not much. Same idea. I am the calculator service, and my goodness, I just want to help the world. Add some integers, maybe subtract some integers, maybe add some strings as integers, multiply, divide, concatenate. All right, that's it. That's all I know how to do. And technically, because I'm a good robot, I don't even know how to do that exactly without a friend. We see here that some sort of an I calculator service provider is part of the lifeblood of this guy, right? It's part of his constructor or her. And so it's a good hint, right? When the constructor of a class is taking in arguments, often these are going to be injected arguments from some sort of a dependency injection container. It's basically the calculator service saying, on my way out the door to work today, I need to make sure I take a service provider. Now, between me and my lunchbox called service provider, I can effectively serve people. I can help. All right. Now, what is a service provider then? Well, when we get to add integers, we're just asking that provider to do the actual implementation. So, in a sense, this is routing. There's some controller patterns in here. There's just like, I'm gonna stand in and hand that request off to my lunchbox, and it's gonna give me an answer, and I'm gonna give you that answer. Hope that's useful. All right, so in providers, we have a standard provider and a non-standard provider, right? We may have an enhanced provider. We may do all sorts of different things. So within this standard provider, we implement the iCalculator service provider interface. That interface just references the iCalculator service. The iCalculator service, as you would imagine, exposes those very things we were just looking at. Now the separation here is it's nice to be able to ask yourself from time to time who's around that implements the service provider interface, separate from who's around that implements the calculator service interface, right? Even that could be swapped. So just a little bit of plumbing and nomenclature to kind of get us started. But if we were to stay in the provider for a minute, the standard provider, it actually does do the adding and subtracting. Maybe later we swap these out for a math library or something. And it has a general sense of keeping an eye on its own self, right? It's kind of protecting itself from how others might interact with it and attempting to throw useful and valid exceptions, etc. And if all goes well, it'll do the math, and return the answer. That's all it knows how to do, right? Just answers for the service. Now, if we move to tests, we get to see our first exposure, right? Like we had potential, we had a very eager robot that in cooperation with a little friend can serve and do really cool things. But that's like a hammer sitting in a toolbox with the lid closed. It's a hammer that can do things. We have to make it do something to really exercise it and see it operate. And so here we have what are called unit tests, and we've just gone really straight with some X unit. We've done some inline theory data here, and we'll look at that. And then over time, we're going to do this differently. We're going to make it even better. But this is a fine place to be. So we had a calculator. We want to know if it can do basic math. We're going to need that service and provider because that provider goes into the service so that it can do its work. Now that we have the service, we can go around and ask it to do work. And we can use this shorthand notation over here called fluent assertions to do our assert should be equal, and it wraps up all the failure conditions and gives us the nice reports in the end about what did and didn't pass our logic within our tests. But these are pretty straightforward. So I have a theory here that if I provide these blocks of data to this method and it takes this service, it's provided itself and goes ahead and asks it to add these integers, then we should get that third value each time, right? And we go down, can we subtract, can we multiply, can we divide, can we concatenate strings, do we concatenate strings and not lose things, etc. So if we run these tests, if we come first here, first thing we're going to notice is they are insanely fast. So if we come in here and mess up one of these and rerun it, they're insanely fast. They don't have any overhead. They're not doing much as far as like there's no networking, there's no systems invocation, there's no database connectivity. This is just code talking to code in a very, very close relationship. All right, so we're happy, right? And building these, of course, they were unhappy and I had to fix things, and it's a wonderful opportunity to take sort of the theory you have that you've made a nice little robot and that it's eager to serve the world. Well, this is the first time we're exercising that. And you're going to find refactoring, you're going to rename things, you're going to move things into different files and break them apart. Like this is a first moment to kind of do this before you build refactoring or as you build refactoring so that you do make something pretty healthy as you go. Otherwise, you leave messes all over the place. Things that should have worked, except under certain conditions, they didn't, right? For instance, we could go over here to the can fail basic math. And so we're even checking, do we throw appropriate exceptions? Can we handle funky situations, right? It's good. All right, so that's pretty cool. If we wanted to teach the system how to now subtract 2 and then multiply, right, or something new, then we might start here. Ideally, we start here, we design the test, we understand how we'll use it, and then we work backwards to build the provider and the service to support that test, and eventually the test passes, right? That's your failed test first, or your red-green testing. There are other ways, and we'll look at those. All right, so we're happy. We have our test. Our test proves our system works, but it's still not very fun. Most, especially if we're trying to convince young folks to get into the industry and to have fun with this, they're going to want to do something, maybe even ship something to their buddies, right? And so let's dive now over here to the console. Now the console, just a pretty straightforward console app, continuing to show and promote best practices and things like this. So we did bring in a simple container. In this case, we're using structure map. So in structure map, we can use the dependency resolver to discover which provider we have. Um, in this case, these are described here, but at least this is, we'll get more and more external to the project. But by including this DLL, so to speak, we have the standard provider available. If we flopped it and we implement it, if we presented the non-standard provider, it's going to discover which one of those are available and it'll plug it in for us, right? So that's per cool. Back here. So now we can get the calculator service that's available and forever. Ask for two values. Ask ourselves if they are numbers. If they are numbers, do some number math. If they're not, do some string math and go again. All right. So first number 34, second number 33. We got 67, and life is good, right? We could go again. So this was a lot more fun, right? It's definitely an opportunity to look at some pretty simple language syntax and ways that we ask the robots, work with the robots to do stuff. And so this is an important part of the journey for our little robot that just wants to help the world add and subtract. This is sort of the first moment that it could do that, but it's going to do that by way of an executable. So if we were to come look at the final result here, we have this executable that you could share around or whatever and run on people's machines. All right, so that's pretty cool, but gosh darn, that's not nearly as fun to share with our friends, and maybe half of them did have Macs, and maybe I'm wrong, and it's hard to get a console app exe ported across. Can't be. Now what do you want to do? Enter some web technologies, right? Maybe the first thing you want to do is expose your calculator on an API endpoint so others could add it to their game or add it to their situation. You want to make your code available for others to take advantage of. So that'll begin with an API. And so if you aren't familiar, APIs are the RESTful, which just means it uses the HTTP action verbs and is otherwise at a rested state. So you can do gets, puts, posts, deletes. I think there's a few others that are sort of supported. And the idea would be how do you talk to an external critter? So we're going to need a couple of windows to see all this come together. First, we're going to go to this API here. Fire him up, and that's going to take this calculator controller that we have created. Again, injecting a calculator service. In this case, we have some other things we're about to play with, but most importantly, get calculator service. Are you awake? Can you add two numbers? Great. And then we have this do action post method that we've exposed. It's going to accept a do action behavior request. So when we want to ask for something, what will we provide? A do action behavior request says here's a behavior, value 1 and value 2. Okay. So if you push to our endpoint a well-formatted request that includes value 1 and value 2, and then I wrote a switch statement here, just again to exercise languages, we'll learn why these become code smells and what we can do in place, but it was fine. We're early, we're learning. And so this switch will then toggle between add and subtract and multiply and divide and add strings, right? Kind of doing exactly what a controller should do. Barely, helping with formatting and validation and data consistency. But for the most part, just sitting in the middle, mapping a request to some business things that can give a good response, maybe tidying that up and sending it back. All right, so now that we have this API, If we were to just visit this in our URL, we get the number 8, and we can kind of see that journey it went on, right? We issued a GET request against this endpoint. We got back a positive 200, it says things worked, and then in our response, we got the number 8. So for things that are a little more complicated or trying to build up a PostBody, it's a little easier to use a system. So we're going to go over here to do action, try it out. We're going to say 55, 54. We know behavior one is add, and we got 109. That feels correct. All right. So that's pretty cool. We could try some other behaviors like multiply or divide. And again, our friends could technically uh, interact with this API endpoint. We could design security around that or leave it open to the public, different rules, etc. So there you go. Pretty cool. We have a request that includes these 3 values, gets posted against that endpoint, and it does its math and gives it back to us. All right, well, that's fun, but not everybody wants to consume API endpoints, right? We're slowly working our way out. We're chasing the holy grail of everything we build in software, which is how in the world do I move this further to the edge of reusability? How do I get this out there to the point that others could take advantage and benefit it in some way? So enter Blazor, Angular, Discord will continue to go on these journeys, but for now, if we look at Blazor, we come back over, we did run that. So if we come and look, all right, so over here in old Blazor, we just chiseled up a little UI. So let's look at Blazor. And let's dive into this calculator. There is the layout. There we go. Pretty straightforward. Blazor. Playing with some CSS and translation and doing some other things. We're going to load this project up with a little bit of everything. But we see here an opportunity to provide some values, choose a behavior, calculate, right? And, as we go, we got to build little things. So the idea of being able to iterate over an enumerable or an enum set and turn that into a drop list, for instance, these kinds of things. So if we come over here, pick something here, then we see, same as before, the do action endpoints being hit. It's a post this time. Posts have bodies. So here's the payload, behavior, value, value. Cool. Okay. And we can do stuff, and if we freak it out, it has some amount of error handling, right? All right. Pretty cool. But again, I promise we were here to learn about tests. So we had those unit tests. Those are fast. Those are wicked. Love those. My favorite tests of all time are end-to-end tests and sort of simulated UI tests. Oh, need to move it down there still. Where are we hiding these? All right. So if I leave these critters up and head over here, this is going to take these feature files that describe how you hope and wish the system to behave. You can provide table data, different ways to get data in there. Essentially, this test is going to run 5 times and provide these records each time. And it's going to try to run through pre-work and then any of these given when then scenarios trying to be happy. We saw a similar pattern in the unit test. The difference here, if we follow, the Blazor side, is we took the calculator page that you see over here, and every one of the important fields has an ID tag. So over here, we just bound all of those IDs up so that they're pretty easy to work with. We've created a model of interacting with those on the page that make it pretty easy for us to automate or simulate page navigation. And then the step definitions bind the difference. So taking that very human readable syntax along with values that might be injected into the method, etc., and binding that to those various page objects we've created that describe what we want to happen, right? We want you to navigate to yourself. We want you to set these form values. I want to see what the answer on the page is reading right now, right? So if we run these critters, these are going, we could tell it to run headless, so you wouldn't see it. That way we can deploy to Linux environments that don't have UIs, etc. But we left it on for now just so we can watch it go by. It's kind of fun, especially again when we're learning. And these are some of my favorite places to start in a lot of different corporate situations. If we can get a team together and maybe we've never authored tests and we can write a couple of unit tests, fine. But when we start writing these end-to-end UI tests and we begin crawling the web and clicking buttons and waiting for screens to load and moving around, just like we did there, um, if we, I'd slow it down for you. Maybe I'll slow it down in post-production, but it's coming in. It knows how to find this Dropbox. We've asked it to pick something. If we go back to that feature file, add, subtract, multiply, divide, what numbers, what should be the result. And it will run these all day long, right? We can be certain over the next 10 years, anybody that touches anything, that stuff still works. And that's kind of the biggest part, right? All of this is, whether you're writing teams for your own project or you're helping others, which is what I'm really trying to help my kids understand in their first round of development professionally, perhaps, is why not just help? There are so many shops that have great products that are basically stable and they're basically doing a good job and they're all trying to run forward. And every day goes by, the mystery and the allure of what we get and don't get because we haven't invested in our testing architectures. Um, hmm, to come along beside a team or for your own team to be able to help spread the ease in which we can create these automated tests, the huge benefit and immediate payoff we get from doing so, the incredible improvement of code maturity and confidence amongst members as they use these tools to the whole point, which is bravery and making it safe to be wrong and try stuff and build in this incredibly difficult environment these wonderful solutions. And know that as we put those out into, maybe our enterprise environment. They have to go live in a neighborhood somewhere, and they have to be good citizens in a neighborhood, and they often show up with, many pieces that need to situate in many places. We start to move towards cloud and cloud native and architecting these using those kinds of patterns, which again is beyond all of this, right? We would do things very differently, and so getting people caught up and comfortable and confident. So as those cloud native conversations start appearing, we don't lose a huge portion of the population that has been suffering imposter syndrome, right? If you're sitting out there and you're like, man, I don't get any of this, or dependency injection and discovery of dependencies and inversion of control and interface, like there's a high I've been in your team. I've coached you. And time after time after time, your belief that you're not getting it or you've been here and these words aren't resonating correctly, it's wrong. You just need different metaphors. You need different mental models. You need environments where it's encouraged to try things and be wrong, and the systems support you and come back and say, "Oh my gosh, you got really close." No, right? Um, so keep at it. Ask good new questions. Build mental models as we go. It's not important that you memorize syntax. It's that you understand what's possible and what kinds of things we need to deal with depending on where we want to go and what neighborhood and environment we want to live in. If we're going to be an API endpoint or a WPF local installed app or a Angular mobile app, or we're going to just be a library that runs in the background and sits on 1,000 machines ready to answer 1 million requests for does this string include this language, right? There's just so many different places that your code will need to know how to go live and how to behave and how to defend itself and how to provide those great services. Take it on a journey. Explore and learn and be flexible. I'm using Net 5 here, and everything you see here and everything I just demoed, I did in one sitting, one very 15-hour long sitting, but I was having a good time. Um, and some of these, like the pub sub, is not here, right? So it's not like this whole thing's done. But how much longer will it take me to stand up a standalone Signal R pub sub socket exposed server that all of my apps can use? And I tore out a little bit of identity. We're going to come back. I'm going to stand back up the identity server. It's on the back end capable of authenticating with Active Directory, lots of different Active Directories, social authenticators and Googles and all of these, username, password, the whole nine. But then that one authorization provider has to be able to extend itself to the API we talked about, to the console we talked about, to the Blazor and the Angular and the Discord bots that we're going to talk even more about. All of this because one silly robot wanted to go on a journey and help people add some numbers. I hope you got something out of that. Until next time, just keep leaning in, ask better questions, right? Don't worry about the answers, worry about the questions. That should be all of our responsibilities. See you later. Cheers. Do 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 do.